Rescue, Data and Repair. My name is Dr. Ben. Hello, welcome, and today I show you how you can repair a Face ID on an iPhone 13 Pro Max with just that little cable and that programmer I2C success. Let's go! Removed the dot and the infrared cam. What we need to check now is, can we still access that chip on that assembly? We can. We need to get this one back here to the assembly, okay? You can see that? I just did some research before on this phone. It's like we can't read data out of the old dot flags because it's an I2C breakage, so we can't get connection to the chip, or the chip has an issue. So at this point, normally it's time to tell the customer we need to do an Apple certified repair. So we replace the true depth camera system, and it takes a lot of money. But before I do that, I would like to check if I can't find a way to get data out of the old Romeo IC inside the dot projector to transfer the data here to that I2C flex cable. So normally, if the dot projector has been deactivated after a repair or after water contact, it's just like we need to connect the assembly here. We start our I2C success programmer and we click on detect, and you see here abnormal, the fields are abnormal, but here the chip I2C is abnormal, and at this point we can't read the chip because we get a read failed. I want to see if I can find a way to get data out of the chip, and if yes, we can copy that data to the chip which is integrated on this flex cable and then transplant the dot projector from one to the other flex. Okay?
Sounds interesting.
Okay, let's see if we can get it. I just turn my I2C 6S, my beloved I2C 6S programmer off. And now we just start by heating up, getting some heat in the system, and trying to figure out a way for repairing this issue here. So I just prepare my hot air, and at first I just want to remove the glue which is here on the top. Okay, so gently. After we did that, it's time for a little cut here. We could use a grinder too, but the grinder is on my other table, so I just use my Knipex for doing that. And as you see, if we work gently, we can find a good way. So now we just need a wipe and removing the rest of the glue here on the back side. Like this. Now we take a look under the microscope. How does this look like? And as we can see here, it's just like we have one point of solder here, which we need to remove. So I just take some flux here and we need to take some good wick, some solder wick. And then we just need to take our solder iron and take this solder away here. Let's have a look if we are already fine. Almost. So we can just remove that shield by hand here. And we can have a better look then. Like you see, the solder which we need to take away is directly here at this point. So now we just start by taking away the solder here. Should be okay. Check again from the top, and you see this is good. Okay, so it just holds. Just together, and we are fine. We are separated. And now we are at the point, and I do it under the microscope so you can see it, that we can split. Now we can just split. Or what we can do is just remove here we are. Removed the dot and the infrared cam from the housing. Okay, so and the chip which has an issue is this one. So we can't read the chip at the moment, and because we can't read the chip, we can't get data out of it, and if we can't get data out of it, we can't repair the Face ID. So let's see. We click on test, we click on detect, and still I2C is abnormal. I thought perhaps because we just used some heat. In some cases, after using heat and we had an issue under the chip, it's like it works after, but here not. So we can just try something now. And what we can try is that we heat up the chip and give it a little kick. So we add some flux here. So we gave it a little kick. And now we can just try to read again. Still abnormal, so that's pretty shitty at this point, but perhaps I have an idea. Give me a second. I'm back again here, and I have an assembly out of a data recovery job. Let's see if we can read that. We can read that. That's pretty okay. So I think we should now just cut that assembly off, and we do now exactly the same what we did before. Okay, we can lift it off completely here. We just need what's inside, so that's pretty fine. And we go straight under the microscope. For doing what, Tim?
I don't know.
You don't know, but I know. So we just separate the dot from the rest of the assembly.
You can see it on the microscope.
Now? Okay. So let's split that. See if we already can get it. Some more heat, done. So what we need to check now is, can we still access that chip on that assembly? We can. And now we just try something which could be the game changer in this situation. So let's hope that it works. So we prepare this one. And we take this chip off here. Oh, I need tweezers, Tim. Yeah, sorry, I don't have tweezers here. Die rote, die AK. So we need some tweezers, and with the tweezers, we just take out that chip here. We lost a small part here, but this is unnecessary for just copying data here. Thanks. So. Do it like that. So we take off this chip here. This is number one. Now we just need a little bit of glue tape. So sometimes we need to try out things to just get a result. So we should give it a try, I think. So we add some flux here. Now it's important to work gently. Okay. Take this off. And we need to get this chip down here. See, it moved. We are here. And now, just hope that this works. Detect abnormal, and we can read the chip. Tim?
Yeah.
We can read the chip. Perfect. And we write the data now down to the new flags here. Okay, write is completed. Good. Now we written the data to the new flags, and now we need to take off this flags from the backside of the dot and the infrared, and then we just need to get this to that cable. Okay?
Let's go.
I try my best, Tim. So I try it without holding because I don't want to break anything. So we just heat it up. And it's like this one is glued to the back side. You know what I mean? So it's glued to the back side. So we just need to work gently. Now we are behind the dot. So here is the dot projector. And what we have here is the connection. And the connection here is like we just need to get it away. It's like you work on the infrared cam on the backside of an iPhone 11. So, and yeah, try to show it to you here. It's like we just need to peel it off, okay? See, this worked fine. Perhaps, or in this cam. So this worked fine. I go straight under the microscope now. So now we are here. And this looks pretty good. Now we need to solder the new I2C flex cable to the back side of this dot. So therefore I just remove glue. You see there is some glue here on the pads, and as long as we have glue here, we can't solder down. You see, I'm not talking much because I'm concentrated at this point. Okay. Gently. Don't use too much power here. Just really gently on that. And just remove glue so the cable can go down smooth. So, and now we just need to solder down that flex down to the back side of the dot, you see? Or to the back side of the infrared and the dot, okay, to the assembly. And this is something we need to do by using solder iron and a little bit of solder even. Okay, let's give it a try, Tim. We just place it down in the right way. Okay, and I just use some points to fix it. And after I got it fixed at some points, I just go over the complete rest, okay?
Yes, sir.
So, for a better way of work, so now I just go over one time. To get solder everywhere. Like this. And now here some more flux. And you see you have these holes here, and these are the holes where you can just put your solder iron on. And this works fine. See? Tim,
Very smooth.
does it look okay?
Yes.
Okay. Now we just clean that. And later we just do a piece of glue tape behind. Now we just have a look. If we click on detect, okay, everything abnormal. Perhaps something isn't connected right. Not a problem. We just need to add some flux and just Give every point a little push with the solder iron to see it's well connected. Ah, okay, I know what I did wrong. I didn't activate the chip at all. So I just soldered down the cable on the backside and I'm pretty sure it sits fine. What we need to do now is just another thing. Tim, sometimes I think that I'm crazy. We need to clean that later. That's
Always think that.
so. Now we need just to remove this chip. Okay, remove this chip and we need to bridge some points because otherwise it can't work. We need to activate the chip which sits on the flex, okay? So, and therefore I had to need to load down the solder temperature of my iron. The iron temperature. A little bit more down. Yeah, this looks good. Now we should get a good result. We go back to here. We click on detect. And we are fine, Tim. All is normal. All is fine. We can now just clean and then get the assembly back to our front system, okay?
Very nice.
Very nice, yes. So now we just need to take a look. Clean that sensor gently. And a fresh wipe. I have another fluid which I can use for that perfectly. But it's okay like this. And now we need to get this one back here to the assembly, okay? You can see that?
Yes, baby.
Okay, so we now just get that back here. Yeah, this looks good. This looks good. Okay, like this. We need to just buy our rice in this case. Then we need to add some glue. Like this here. And then we need some heat. Apply heat from the side. This is not a UV glue, this is a glue which hards on applying heat. So we now need to add some glue here at the side. Okay. And again. Heat. Yeah. It's too hot, okay. Now it hardens, it comes, okay. It's always, if you work with these glues, just need to work gently. And this here looks pretty fine. Need to come down a little bit more here. Looks pretty good. Okay. Just reheat a little bit and give it a little push for going down. And after that, we let it stay for about 15 minutes for harden out, and then we just run a test, okay?
Maybe.
Okay. Now really let it stay. Before we just retest it one time, we click on detect. All is fine. And now we let it stay here. After that, we will get a little bit of glue tape to the back side, and then we will mount everything and give it a little test run. But we need to wait a short time. I hope this is okay, Tim.
Of course.
I will take a cold flush of Flötzinger in this time. Then I come back and we just test it, okay? People, we have a little cut. I'm sorry. As I was ready with that, I just wanted to boot the phone, and I didn't even boot the phone before because it comes from another B2B partner from Austria, and he mailed in the device for repair, but of the dart projector. So he said, dart projector issue, please repair. So I did all this, what you saw. Then I just wanted to test, and then I recognized the screen has no function and the board had an issue too. I show to you what issue the board had, because it doesn't want to boot. It was going to 10 milliamps and then back to 0. And the issue which we had in this case was the phone was dropped before, I think. We had this coil, and this coil was just completely missing. So I had to replace that. So now I want to boot the phone without resoldering the board halves back together, just the top layer for a test run. And I had to fix that at my table, because here I hadn't all the tools, and I had to run to my table and come back to here. And this here is a dart projector repair video, not a logic board repair video. So I just fixed the board, and now we can just give it a test run. Does the Face ID work again? Tim, is this okay? You saw all this, you can prove that I'm right.
You trust me, Dr. Ben?
Yeah, so it's really like you do repair like this and you're hyped, okay? Okay, everything worked smooth and fine, you want to test, and then you can't boot the board. I just do it like that so we have more space. Then you just want to test and you remember that your B2B partner mailed you a device with a non-working board but didn't say anything. If the device comes from an end customer, then you check that before. But if another repair shop mails something like this to you, you normally think that they should be right with their diagnostics, or even mail you a device which just works. You see here on the flex cable, I showed to you under the microscope, we have a print. And you can see I2C. So you see, that's the right flex cable. I just took a new screen. And now we just give it a test run. What I did is just transplanting the EEPROM and overtaking the front flex, okay? So, all things...
Video on that, by the way.
Yeah, we also have a video about how to do that. So, and now, just let us see if we can give this device a test run and we have a working Face ID again, or do we have to charge the battery? I don't know at all. Let's see. So we just get the cable into the device and then we just need to wait if we can see something. Yes, the device charges. What do we do now? I just go to my table and charge it with a faster charging adapter, or do we have something here? No, I just push the battery like ever. Okay, just a second. I just charge the device. You see it works, and then we check Face ID for function. Now the phone has been charged about 3%, and now we have a big problem. And I could totally. We have no code, so I will show to you, it's a personal background image. Tim, you have to blur a little bit, but here you can see it's 4%, it's power of the battery 4%, it's charged. We don't have a Face ID error message. If the dart projector would be faulty, we had this message now here, but I don't have the right code, so I don't have a code for the phone. The customer didn't wrote the code into the system. Now we just have the problem that we can't test the phone completely. For sure we can do Apple GSX diagnostics, but that's nothing for the use here in this video. So for me it's really bad, because I wanted to give you a full video solution from point 1 to point 10, whatever, so from A to Z, everything, but I can't do anything here in this point.
Have you tried the code 000?
Yeah, I have tried, and you saw it just doesn't want to work, and I don't want to risk anything like deactivation. So I just wrote information to the customer and to the system. Now we just wait until we get the right code for the phone. Then we can do a full functionality test. Even we have to resolder the board halves back together, because they are separated at the moment. So it was just a case like we get a phone, they say it's a dot issue, so I repair the dot. My I2C success programmer, my beloved, says everything is okay now. Then I want to test the phone. Then I see, oh, we have a problem. The phone doesn't want to boot, the board has an issue. Then I repair the board at this point, and then I want to test everything and show you the Face ID works fine, because here we did a good job, we did a good job, we did a good job, and then we don't have a code. So I hope you liked the video anyway, Tim. I think we should get it up anyway, because the process at itself So we get an I2C message. We can't read data out of the old chip, but we can. If we just give that chip to a new flex out of another iPhone, we can read the chip, we can get the data, and we can write data onto a new flex. And after that, we will have a Face ID again. So I think that's a really interesting process in it, because this was what I thought as I saw I2C abnormal. I thought this isn't the chip. Why should it be the chip? Why should the chip be that? That's not the issue. Mostly the issue is that the cable itself has a short, a layer short or layer breakage, whatever. In this in this situation, I think for a layer short, so a line which goes under the chip is connected to ground, and then we have the issue that we have I2C abnormal, we can't read the chip. So don't think you need to do an expensive Apple certified repair in this case. Transplant the chip to a known good flex cable, then read data, write it to the I2C flex, and then transplant the flex on the backside of the dot, and you have a working Face ID. I would really like to show you that, but I don't have the code for the phone. I hope you liked the video anyway, and we see us with the next one. We have something really special which is coming up. So stay tuned, give us a thumbs up, like, subscribe, whatever. I'm out. Goodbye. Here's Dr. Ben.